keep that comparison in mind. Notice that one of them was dipping a little bit more than the other one during the throttle pumps. This video is going to be very much more just me talking, kind of like podcast style. There aren't going to be that many visual aids. There will be one primary visual aid along the way, which you don't really need to even see. There is a link down below for you to download the MP3 audio, because I don't know of any podcast source that just is easy as YouTube. So I've kind of made the MP3 available. It's hosted on my Google Drive. I'll host it there as long as I can, as long as it's not a problem. So what I'm going to be talking about is kind of maybe possibly the next generation of stuff, of improvement in our mini quad flying. So before moving forward, let's talk about, in the past, some of the issues that we were having. Originally, or over the past couple of years, the state of our hardware and software has changed and improved considerably, like massive changes. A quad from 3 years ago flies like absolute trash. And I would say it's more because of the software improvements that things have improved than anything else. And so when we look at the first original motors and things that we were using, the motors were not really not powerful. They were powerful, they just weren't as highly constructed as they are now. And our software is way faster now, and all of our hardware is also way faster now. But there's a couple things that did change, maybe for the worst. So back in the day when we were running like 10, 12-inch props, like massive things, because everybody thought, oh, you need 10-inch props just to get off the ground, we were using ESCs that had these massive capacitors on them, and were basically just built more hardware than software, and they just worked okay. Nobody really cared, and also all the code was kind of dull and didn't really respond really quickly. So there really weren't that many issues, because the issues would just get lost in all the dullness of the system operating on its own. Fast forward to today, now we have extremely powerful motors that are extremely responsive, as well as our hardware. Our ESCs have lost their massive capacitors. We've kind of stripped everything down to its minimum. We have traded the massive electrolytic capacitors for a bunch of little tiny caps and one primary electrolytic capacitor, which is arguable if it's good enough to deal with everything or not. Still, the jury's out on that one. But also, our software has gotten way, way, way faster, and our processors have changed to get to the point where they can actually operate or execute the software, as well as the ESCs have gotten way more responsive and also way quicker at dishing out the instruction set to the motors to actually respond to get everything to work as it is. So along the way, we ran into a number of issues. One of the primary issues that we ran into, well, let's back up a little bit. One of the biggest issues with mini quads is that the PID tuning has been an absolute pain since the very beginning, since the inception of mini quads. PID tuning has been a pain, and primarily we really just tuned the quad to try and get rid of prop wash. Now that's the primary discussion here, is prop wash and response, which I'll get to in a minute. But there are a couple other issues that appeared along the way that we recognized. So one of those issues were kind of these ticks or oscillations or wobbles or things that were caused seemingly by electronic or hardware vibration noise. And so people did a host of things to try and solve these problems. They put tape under their motors, that's what Johnny Sher used to do back in the day, and then people started making TPU pads for the motors. I myself came up with a number of ways to mount the flight controller to try and isolate it from these vibrations. I started calibrating my TPU flight controller mounts for specific quads. It's ridiculous. And then another issue, which was the overloading of the ESCs and just falling out of the sky, which is whatever. And then there's another issue, which is the dipping of the quad, which is what I showed you at the beginning. This dipping of the quad, I originally thought it had to do with the ESCs, the quality ESC, the ability for the ESC to respond and execute and all this stuff. I may have been slightly correct, but I was probably more wrong than correct. Another problem was improvement of the control or the response of the quad. Anyways, you get the idea. There are a host of problems that we recognize along the way. So there's two companies now, Brain and Helio. These two companies are doing things a little bit differently than pretty much every other flight controller out there. They are focusing, well, Helio is focusing primarily on filtering only. They only deal with filtering of the information coming out of the gyro and giving that filtered information to the flight code to execute. And Brain is focusing on kind of everything, but they do a couple other things. So they are using a different gyro than pretty much every other flight controller. They're using a gyro from Bosch. Bosch is a company that is massive, and they're a tech company, and they make gyros, and they make a very specific gyro, and they make things in a very specific way, which I'll discuss again in a minute. But basically, their gyro is special because it just tends to be a little bit lower noise than other gyros, and I don't really know why other flight controllers aren't using it yet. Maybe they're thinking about it. Maybe they can't get it because Bosch wants like millions of gyros sold to be able to use. Who knows? But Brain is the only one using this this gyro, and the Brain flight controller, as far as I know, has become, I think, the primary flight controller of choice with the X class, and it's because it tends to do better with the vibrations and it's easier to deal with. Now, that's not their only focus. They also have a very nifty OSD, but I honestly think that the main focus that people are focusing on is the flight performance of the flight controller. KISS is also, I'm sure they're doing something, and they've always flown great from the very beginning. I'm sure they have some kind of proprietary stuff going on we don't know about because it's always been closed from the very, very beginning, and I'm sure they have another development that's going to come out when all this stuff kind of matures as well. So both of these companies are kind of sort of focusing on the noise, filtering the information coming out of the gyro, which is the important aspect, which seems to solve so many problems, it's kind of eerie. But let's focus on the gyro itself first and just talk about that. Solid-state gyros came out like 10, 15 years ago, maybe almost 20 years ago now, and as far as my knowledge goes, I don't know if this is actually the first product, but I think one of the first products that started using the solid-state gyro was the Nintendo Wiimote in the Nintendo Wii, and it was kind of revolutionary. And then I think one of the next big consumer products that was using the gyro was the iPhone. I don't know if it was the first iPhone, I think it was actually the third or maybe even the fourth iPhone that started using it, but it was also very revolutionary. It was a very interesting thing, and one of the very first flight controllers was called the Multi-Wii, and what they did was essentially just hack a Nintendo Wiimote to fly a multi-rotor. So let's look at this solid-state gyro, which is not actually solid. If you look inside, from the outside it looks solid, but if you look on the inside, it actually has moving parts. So I'm now showing you a video on screen. This is one of the only visual aids that's in this discussion. You don't really see it. I'm going to describe it. The link to this video is in the description below. It is very interesting. It is also kind of a rudimentary view of what it sort of looks like. So here's what's happening. This is a little sliver of silicon, and they're feeding electricity through the silicon. It's called a piezoelectric system. A little bit complicated there, whatever. This thing vibrates. It vibrates, and when you move it in a certain direction, because it only has one axis where it actually responds to movements, the piezoelectric unit, which is vibrating, twists. And it feels this twist, and this twist comes off as an electrical change. So in order to get a 3-axis gyro, you need at least 3 of these. And the reason I say this is kind of an artistic rendition of what's going on inside is because this is what it actually looks like. This is an example of I think it's an electron scan. No, it's not an electron microscope, but it's a very high magnification scan of the piezoelectric system or the gyro system inside a gyro wafer. And as you can see, it looks like there's a multitude of these little silicon things that are probably jiggling in there and giving you readouts. So right off the bat, when I saw this, I thought of a host of things. Now this is a mechanical system, and I'm like, okay, well then this is mechanical, so it should wear, and it should change with the design, and you should get totally different results based on the size, the amount of electricity you feed through it, how you feed electricity through it. There's a host of ways to manage this system to get different results, and that's essentially what companies do by creating different gyro things. It's like making a processor. They can get different results depending on how they use the silicon in the processor and the traces to get whatever they get. Let's first just think of a couple of examples that these things can vary. If you wanted a 4K gyro that's limited to 4K and only reads at 4K, then you should make your piezoelectric element such that when you feed the piezoelectricity through it, or the electricity through it, it vibrates at 4K, and so you take readings at 4K, and that's all you can do. You can't really change it because it's limited by hardware. Like the hardware cannot vibrate faster. And this is kind of, I'm extrapolating this. I've read into this, but I haven't really read into it too far. I'm sure you guys in the comments below will correct me. I don't know everything. I'm just giving you a very general kind of idea of how these things work to give you a conceptual understanding. So 32K gyros probably they do, but I'm saying probably because I don't know, have an element that vibrates at 32K faster, and so they can read at 32K. So right there you see that there's one that vibrates at 4K, one that vibrates at 32K. Maybe the thinner, smaller, probably thinner and smaller 32K element is going to wear out faster than the 4K element. And this is actually true. Gyros do wear over time, and the data does change over time as it's coming out of the gyro. Now, I couldn't find information on how long these things take to wear, but I'm sure it happens, and as some of us have have experienced, we can crash and just break the gyro entirely. It doesn't look like it's physically harmed, but it just doesn't fly correctly anymore. Anyways, this is just one example of the hardware limitations of these gyros and basically what these companies have to go through to engineer a gyro. In addition to these elements, these vibrating elements, all companies, all gyros, have a processor attached to, this is one other visual aid I forgot to say. This is the last visual aid. There's processors that are attached to these gyro units within the same solid state core. These processors are things that every company that makes the gyro have to deal with and encode with ways to, or software or some mechanism to deal with a couple of things that I can just think of off the top of my head. Number one, the electricity coming into the gyro. It needs to deal with the fluctuations with the electricity. And that right here, you can see why electrical noise can cause a problem with gyro reading. If you have a lot of electrical noise coming into the system, you have a lot of noise going into the gyro, and if the gyro can't deal with all this noise, or if you don't have the proper electronic filtering to deal with all this fluctuations in voltage, then the piezoelectric system can't function optimally, and you get weird readings coming off the gyro. So that's one thing that it needs to deal with. Another thing is that it needs to actually deal with the information coming off of these elements as well, and then feed out information that software or something can actually deal with and interpret. So this little thing, this little processor inside the gyro does quite a bit. And this is where brain comes into play. So the company Bosch makes a gyro that they have tuned software in there for vibration filtering, which is pretty darn interesting because that's exactly what Helio does, except they do it in a different way, a roundabout way. So I'll discuss that in a minute. So the gyro that brain is using is in fact probably better than pretty much all other gyros with the way that they're using it, because it has filtering built in. It has, from this company Bosch, which is a massive company, has engineers that are really, really experienced writing this code for filtering. But, and a big but, they don't have a specific mini-quad gyro. They have written general code to deal with general vibrations. So we don't exactly know what it's doing, but it seems to work well for mini-quads. And I don't know exactly which gyro they're using, but I do know that I looked up that Bosch is coming out with a new gyro that's specifically designed for multi-rotors. But I don't know if it's designed for racing multi-rotors, which I'll discuss more in depth in a second as well. So Brain actually is getting a real life benefit here because they're actually getting cleaner information out of the gyro. So that's why they have an advantage over everything else. Now, what is Helio doing? Helio actually uses gyros that have as little filtering as possible, and I'll say why about that in a second as well. And what they're doing is that they're using their own custom code that they've written themselves to deal with all this noise coming off the gyro, or not noise, just deal with all the information coming off the gyro and interpret that information and then feed that information out into the flight control software, which can then do its job without having to worry about any filtering. So right there, that's a massive difference between Brain and Helio. So Helio does 100% of all filtering. In fact, if you do install Betaflight on a Helio board, it has the filtering mechanism removed out of the code. Like, you can change filters to whatever you want. It does not matter. It's all done in the Helio, and then the flight code does its job, and those functions do nothing. Whereas in the Brain board, you still have control of the filters in Betaflight or whatever code that you run on that board, because I don't know what's going to come out in the future. So hard to say which one's better, but I would tell you that a lot of the problems that we have been having in the past have to do with the immediacy of, or speed or delay of information being fed into the flight code. Prop wash specifically has a lot to do with filtering and the delay of the filtering when it starts interpreting the code. So the more filtering you do, the longer it takes and the slower the data is to get to the flight code to interpret it and be able to do its job. So which one is faster? Well, that's really up for debate. Multiple filters filtering through multiple processing may not be a good idea, and the information that's coming out of the Bosch gyro may actually be delayed from the get-go, and then you add the Betaflight filtering on top of that, and that also seems to maybe delay it more. Well, the filtering has gotten a lot better in Betaflight. They're now using Kalman filters or some rendition of Kalman filters or whatever filters, whatever it is, it's gotten a lot better, and now prop wash is almost negligible, but it's still there, just a little bit, it's still there. Whereas Helio is using totally proprietary algorithms now. Yes, they are using some rendition of Kalman as well, but they keep tweaking it, keep tuning it, and they're doing it specifically for mini quads. And they have one massive filter, and they have one massive processor that's doing all of this processing, and it has ample headroom to do plenty more processing as well. And they're just making things better and better. And they can also tune their filtering system for various applications on the fly. Like they can just change the code or change the firmware in that IMU that they're using to deal with whatever application that they're dealing with, whether that be a car or an engine or a phone or whatever that's going on. Various mini quads of different sizes. Like they can actually tune their systems because they personally have control. It's kind of hard to get Bosch to tune something specifically for your quadcopter, but Brain is doing a pretty good job at doing everything they do. But you can't turn off the filters in Betaflight and expect the gyro to do all the work. You still need the filters in Betaflight, but Brain has done a really good job of giving you some really nice readouts in their OSD to be able to tune this stuff on the fly in your OSD. Like, it's really, really nice. So right there, that's kind of the gist of the whole discussion. It's really hard to say which one is better. Do you trust one massive company that's making gyros specifically for specific applications now, or do you trust Helio, these arguably small guys, which are from the community and are just doing filtering and are doing the filtering specifically for mini quads? You know, which one has more intellect or knowledge or skill or experience to be able to do what they do? That's really up to you to decide. And both of them seem to be working fantastic, because talk to anybody that's tried both of these things. Nowadays, they both give you much better consistency than any normal flight controller. And that is really the major improvement that we're seeing, is because already any flight controller flies pretty damn excellent with Betaflight or any of the code nowadays. But the consistency is still a pain, because if you build 20 quads, you're very likely going to end up with 2 quads that fly awesome, 10 quads that fly okay, and then 8 quads that are kind of annoying that you have to deal with filters or fix or do something, and that's really frustrating. And when you use Brain or Helio, you end up with 20 quads that seem to fly awesome right off the bat, and you don't even have to think about it. So I'm not really for or against either one. I love both of them because I love that they're doing something to make things better for us, because things fly awesome, and it's great when things fly even more awesome. I also have no idea what sim mode is. I don't know what they changed to make sim mode what sim mode is, and I don't even know what they're doing with FU mode on the Helio IMUF system. Like, apparently they're very similar. I did try the FU mode on the Helio because I do have a quad with the Helio board in it now. It has 0 prop wash. It literally flies like a simulator now. It's pretty darn incredible. So that's nice. But now let's take it a step further and discuss a little bit more about the gyro itself. A while back, I used to think that a direction that we may end up moving into is multiple gyros. I thought, maybe you can have an array of 5 gyros, and you can have error checking among the gyros, and you can have confirmation between readings of gyros. But now I kind of sort of have flipped the other way. It's probably, I think maybe, based on the conceptual knowledge that I have at this point, I think it's probably a better idea to have one gyro that's super duper fast at giving you readings. And so if you have a gyro on a flight controller that gives you 32K readouts, and you only poll it or only set your flight controller code to 4K, I don't think that the gyro is actually reading at 4K. I believe it's probably still reading at 32K. It's just skipping reads and only giving you 4K. Like, you're only polling that gyro at 4K. And so you're losing a whole bunch of information that the filters could be using to improve flight function or flight quality. And now let's talk about that. So if you have a flight controller that, hold on, let's back up for a second. Our motors spin at, let's say, 30,000 RPM. So the most vibration coming off the quad, I'm just going to throw out some numbers. This is really just a high level conceptual discussion. So let's say our quad is vibrating at 30 hertz, and our gyro is reading at, this is very slow, but our gyro is reading at 20 hertz. So very similar to rolling shutter or jello in video, if you kind of understand that concept. The readings coming out of the gyro may be happening within the vibration of the quad, because they're actually slower than the quad's vibration. Like, it cannot see what's happening in the middle of the vibration. If you increase the gyro's reading to, let's say, 40 hertz, now the gyro is reading faster than the vibrations in the quad. So it's polling in the middle, at least at some point, it's polling in the middle of the oscillation. So if you think about the quad or something oscillating back and forth, or let's say a swing set, instead of just reading randomly somewhere in the middle of the actual swing, you have a data point maybe at the end, maybe in the middle somewhere, and maybe at the other end. So you have more information to figure out what on earth is going on with this quad. Now if you dial up that gyro up to 100 hertz, and the quad is vibrating at 30 hertz, well, now you can actually map out these oscillations of the quad. Which one do you think is going to be easier to figure out what the quad is doing and filter out that information, filter out that crap, those vibrations that we don't want, and then feed the correct or good gyro information to the flight code to be able to execute its function? Obviously the one that's reading at a higher rate, and that's what 32K seems to be. And this is what the Helio guys have told me. 32K seems to be fast enough for them to actually read the oscillations and vibrations of the quad, so they can do much more effective filtering that actually executes much faster, and so they can read information, they can dish out information much quicker and drop the latency way down. This is also one of the reasons why you may notice that your rates on a Helio board are a little bit faster than your rates on any other general flight controller. And they tell me this is because the information coming out of the Helio board is so much faster that it feels faster, because everything is responding much quicker. Now, I don't know if Brain does that as well. I haven't tried Brain. I'm going to be trying Brain very soon when their 20x20 is made available, which I'm very excited to try. But basically, that's their rationale, or maybe the truth, I don't really know, of why things respond, or your rates seem to be a little bit quicker. And you do have to I had to drop my rates. My rates are 1.31 usually. I had to drop it to 1.27 with the Helio board to get the same general effect. So now let's go back and discuss the issues that we were having with quads. The biggest issue, which I think, is PID tuning, which has always been a pain that I still don't know if anybody truly knows how to do, because I don't think they can know how to do anymore, because it was all mixed with the vibrations and the delay of the filtering, the delay of the readings from the gyro. So it didn't matter what you were doing with the PIDs, you would always have problems. Like, you were tuning, it wasn't even a moving window. It's like you ordered a cheeseburger and you got an ice cream sundae. Like, they're two totally different things. But now, with a Helio board, or even now Betaflight, or with the Brain board, I'm assuming, you can PID tune, and it's actually pretty darn easy. Like, you can just move your P's up and down willy-nilly, and you will not induce prop wash. It will tune however you want. So now you can actually tune a quad specific to the frame, specific to the motors. Like, it's actually easy. I don't think that we should get rid of PIDs anymore, because it's great. It's a really nice way to tune the quad. You can really adjust the settings and the way the quad feels very easily. I mean, I still won't do it because I don't care that much, but hey, if you want to, it's there for you. Additionally, specifically with the Helio board and also the recent Betaflights, they are doing a much better job at dealing with the dipping when you throttle pump, like any corner dipping or side dipping. And the Helio board is pretty damn near perfect now. This also seems to be as a result of the improvements in filtering and speed of data that's good coming out of the gyro and going into the flight system, flight code, which is super interesting, which clearly shows that I didn't know what on earth I was doing back in the day, and I'm happy to admit that as well. I'm very proud and excited to admit that I was absolutely wrong, because it's gotten so much better. I'm so happy that it got so much better. But it's just so monumentally interesting to me that all this is the way it is. Also, another point I forgot to make, which is also an interesting point. So another thing people may have noticed is that depending on your environment, the weather, the humidity, things about the quad changes, and your tune changes. It seems like you need to retune depending on the temperature or the altitude. And now it makes sense when you look at how a gyro is constructed, why that does change. When you move the gyro into a different temperature or atmospheric environment, the atmosphere inside the gyro changes as well. If it's not totally fully sealed or something, the temperature changes, so the vibrations maybe become more dull in there, or something may change, who knows. But now it sort of makes sense, because it's a mechanical system. It's not an actual solid state system, which, if it was an electronic solid state system, it should technically be better when it gets colder, but relativistically it doesn't really matter. Anyways, let's forget about that. Anyways, I hope that was really interesting to you, because it was kind of really interesting to me while I was learning it over the past couple of days, and I'm really excited to make this video. I think this is probably one of the most interesting topics I have reviewed. Honestly, like, I'm so interested in how this stuff works, and I don't even know why I tell people to floss anymore. I mean, if you want to keep your teeth, you should probably floss your teeth. That's it. Take care. Bye.